Hello everyone, welcome back to this channel. Today we are going to talk about a real case study, which is Amazon's DynamoDB. It's a real key value store which is used in Amazon AWS. Okay, cool. In this video, we are also going to apply all our previous knowledge. So for example, the hash ring, and also the consistent hashing, and also the replication technique, and also the vector clock. So we are going to talk about all of them and apply all those knowledges to this video in the DynamoDB case study. Okay, cool. And if you're interested, you can read this paper, which was published by AWS. So here you can see it's a paper about the DynamoDB design. So, and all the knowledge we are going to talk about today is all through this paper. Okay, cool. Okay, now, so it's a key value store, right? So basically, let's talk about what the API will look like. So first, as a key value store, I need to write some key and value into the store, just like a hash map, right? So definitely we are going to have a put command, which is we will go give a key and we will give a value for this key. So then it's stored in the DB, right? And we will also have a GET request where we will give a key, and then the value of this key will be returned to the client, right? So basically, these are the two very simple APIs we are going to implement during this system design. Okay, cool. And now let's talk about what's the high-level architecture of this uh, DynamoDB. Okay, so the first thing is because it's a distributed system in AWS, right? So we must consider two things which we talked in our previous videos. First is how to achieve high scalability. The second thing is how we are going to achieve high availability. Okay, so if you are not familiar with scalability, you are not familiar with availability, you don't know what are the common techniques to achieve high scalability and high availability, then you can go back to my previous videos. One is for scalability and the other one is for availability. You can study the basic knowledge there and then come back to this session. So I'm not going to repeat all the details of the two techniques. So I'm just going to go through some high-level technique which will be applied to DynamoDB, right? So first, let's look at the scalability. Okay, cool. Uh, as we talked in our previous video, the most common way to achieve high scalability is that you should distribute your traffic to different machines, right? And the most commonly used technique is called consistent hashing, right? So basically, there is a hash ring here, okay? And there is also machines, right? Which you are going to distribute the traffic to, right? So here, let's say we have 5 machines, okay? Then we will use a hash function. Let's say hash func, okay? So it will take the machine's ID. It could be the machine ID could be a string. So for example, it could be the IP address of the machine, or it could be the uh, actual physical ID on the Mac in the machine, right? So basically, each machine will have an ID, and then you take a hash function, which maps to a number, right? So let's say you have 5 machines, okay? Then you distribute the 5 machines to this hash ring, okay? So for example, maybe this hash ring, let's say it's from range from 0 to 360. So this hash ring, it represents numbers from 0 to 360, okay? And let's say this machine, after we apply the hash function, its number is 36. And for this machine, its number is, let's say, 100. And for this machine, it's 180. And for this machine, it's 280, and now the last machine, it got its number is, let's say, 320, 330. Okay, so then, so this, okay, so the whole ring's number is from number 0 to 360. And for each machine, we apply a hash function based on its machine ID, right? And then we just insert the machine into this hash ring, right? So then let's say we want to store data, okay? Let's say data X, okay? And we use the same hash function, okay? To map the key of this data to a specific number, which is also in range 0 and 360, right? So let's say after the hash of the data's key, and we got a number which is 200, okay? So then we can see, oh, the data X will actually fall into this range, right? Because 200 falls in range from 180 and 280. So this means this 180 machine, it will store this 200 data, okay? So the request will be sent to this machine and it will be stored on the specific machine, okay? Now let's see, we have another data, okay, which is data Z, okay? And it has a key, right? So let's say after hash the key, we got a number, which is 356, okay? So now we can see this 356, it falls into this range, right? It falls into 330 and also 36. So we are going to store the data, okay? So the data falls into this range in the hash ring. So this data will be stored by this machine, okay? Cool. So this is how hash ring works, and this is how the consistent hashing works, right? So basically, you can see we evenly distribute all the machines, all the traffic onto the 5 machines, right? So there could be one problem, which is what if when we assign the hash, okay? What if when we assign the hash to each machine, it's not evenly distributed on the ring? So let's say, what if the ring looks like this, okay? So we have this machine. Okay, let's give it a number. Okay, this is machine A. Okay, cool. What if machine A is here and machine B is here and machine C is here and machine D is here, and the last machine, which is machine E, it falls here. Okay, so now you can see the machines, the 5 machines are not evenly distributed into this hash ring, right? Which means the data, most of the data, many of the data will fall into this range, right? And that means half of the data or most of the data will be handled by this machine D, right? So you can see the traffic is not evenly distributed. So most of the traffic will go to machine D, right? So with this, we cannot achieve high scalability, right? So what's the solution to this? Okay, so the solution to this is we are going to use multiple hash machines, the hash functions. So we can apply, let's say, okay, we can apply 2 hash to each machine, right? So for example, for this machine A, okay, we get a hash based on hash function 1. So we put the machine A here, okay? And we also based on the hash function 2, we also know a different number for machine A, right? Let's say it's here. Okay, so then we also put machine A here on the hash ring, okay? And similarly, we apply hash functions for machine B, okay? So after hash function 1, we put machine B here, but also after hash function 2. Now it will have a new number, and the new number may be here. So we also put machine B here, okay, in the hash ring. And similarly for C, it could be here, and for D, it could be here, right? And for E, after apply the second hash function, it could be here, right? So now, because we have more hash functions, so we mapped the same machine to another machine. So in total, each physical machine will have two numbers on the hash ring, right? So with this, you can see all the machines are evenly distributed, right? So now we call this each machine here on the hash ring as a virtual machine, right? And multiple virtual machines could be mapped to one physical machine, right? So here you can see for machine B, actually there are two virtual machines corresponding to the physical machine B, right? So on the hash ring, machine B is here and also machine B is here. So it has two virtual machines related to this single machine B. Okay, cool. So when a data, let's say, it falls into, let's say, this range, which is between this virtual node and this virtual machine, then we know the data should be stored by machine A, right? And let's say another data comes and it falls into this range, which is between A and C, then the data will also be stored on machine A, right? So with this, you can see with virtual machines, okay, so now you can see the data are evenly distributed across the whole hash ring, right? With this, we can have evenly distributed traffic to all the physical machines we have. Okay, cool. So here we talk about how to achieve high scalability in DynamoDB, right? Now let's talk about high availability, how DynamoDB achieves high availability. Okay, if you remember our previous video, the most common technique to achieve high availability is through replication, right? So basically you replicate the data across different machines, right? Okay, so now for simplicity, let's still use this hash ring, okay? Cool, let's remove the data part from here. Okay, cool. So in this hash ring, let's say, okay, we still have the numbers, okay? So this is machine A, and this is machine B. Okay, and this is machine C, and this is machine D. Okay, and the last one is machine D, machine E. Okay, cool. We have these 5 machines. Okay, so just for simplicity, I didn't use a virtual machine, right? I just use the physical machine to explain how the replication works. Okay, cool. So now let's see, we have a data. Okay, let's see, we have a data X. So we have a key, right? So then we use the hash function to map the key to a number, right? So let's see, after hash, the number is 200. Okay, so like we said before, this data is in this range, right? Is in this range on the hash ring, which is between machine C and machine D. So then this data will be stored by machine C, right? So this data should be stored by machine C, okay? Cool, it will be stored by machine C. And as we said, in order to achieve high availability, we need to replicate the data into other machines, right? So let's say we have n equals to 3. N is the replication factor, and it means we want to store the same data on 3 different machines, okay? So we need to choose two other machines to store the same data X, right? So in DynamoDB, the way it chooses the other two machines is just the next two machines when you walk clockwise along the hash ring, okay? So for example, this data X, it will be stored by machine C, right? So besides storing the data on machine C, we will walk through the hash ring clockwise, and then we hit machine D, and then we hit machine E, right? So this means the X will also be stored on machine D and machine E. So with this, you can see the X data is stored on three different machines, which achieves the replication and which achieves high availability, which is our purpose, right? Okay, cool. Now, another problem we should talk about is the fault tolerance, right? So what happens if some machine dies, right? So let's say in our case, okay, let's say machine D, okay, cool. Let's say machine D dies, okay, cool. This machine D now is dead, okay, cool. Machine D goes down. And okay, let's remove this. Okay, cool. So now still the same case. Okay, let's say we have data X, which will be written to machine C. Okay, now data is written to machine C. As we said, the data must be stored on two other machines because our replication factor is 3. Okay, so as we said, we need to walk clockwise along the hash ring, right? So we will walk it, walk it, walk it. Oh, we found, oh, now we know machine D dies, right? So we walk along the hash ring, we see, okay, machine E is still alive. So definitely we need to write the data to machine E, right? But because machine D dies, we only write one replica of the data, right? So we still need to find another machine to write the data. So in this case, we still continue to walk clockwise along the hash ring, and we found the machine A, right? So in this case, we will store the data on machine A. However, in normal case, the replicated data should not be stored on machine A, right? Because it should be stored on machine D and machine E, right? So in this case, when we write the data X to database in machine A, we will also have some flag to tell, oh, this data X actually it's replicated from machine C and it should be written to machine D. Okay, so this is a special flag we must have when we store the data X along with uh, with the data X. Okay, and this technique is actually called hinted handoff, right? This technique is called hinted handoff because we hand off the data from machine D to machine A. Because machine D dies, so the data should be temporarily stored on machine A, right? So now let's say later machine D resumes, it's alive again, okay? So then machine A detected, okay, machine D is alive. Now let's push the data which are temporarily stored on myself to machine D, right? So in this case, once D is online again, machine A will push the data. Okay, machine A will push the data X to machine D again. Okay, so then now machine D has the X stored, right? So after machine A push the data, then it removes data X from itself. Okay, so and then you can see the replication resumes to its original status, right? So this is called hinted handoff. Okay, cool. Okay, another aspect um, of the DynamoDB is impermanent failures. So let's say somehow there are some network partition, and then uh, some other events trigger the whole system goes down. Okay, which is permanent failure. Okay, now because of previous network partition and because of this kind of failure, the data between the replicas could be very different, right? So for example, the data on this machine E and the data on this machine C, they could be different, right? So we need to sync them so they can have exactly the same data after they are back online, right? So how do we get the data synced between all these replicas? For example, in our case, we have 3 replicas, right? So how do we make sure these 3 machines have the same data, which is in charge by node C, right? So one way to do this, okay, so we have 3 replicas, right? So let's say here, okay, so we have this data. Okay, let's do it. Okay, so we have this data from machine 1. Okay, let's say we have this from machine 1, and we have this data from, sorry, okay, so we have this data from another machine, right? So as we said, we need to sync the data between these 2 machines, right? So how do we sync? So in order to sync, so you need to know where's the difference in the data, right? So we only need to sync the data which are different. If the data are the same, there is no need to sync the data, right? Because in order to sync the data, you need to send the data across the network, right? Which consumes bandwidth and resources, right? So in theory, we should only send the data which have difference, right? So, so one way to do this is, yeah, you just compare the data, all the keys and the values among these 2 machines. So you scan all the data, right? And then see where the difference is, and then only sync the data which has difference, right? However, this is very time consuming, and this is also very resource consuming, right? Which doesn't make sense. So in DynamoDB, it employs the Merkle tree approach, okay? So Merkle tree approach, okay? So what this does is that it composes a binary tree, okay? So let's say this range, okay, this is a data range. Let's say it's from range 0 to range something, okay? So now let's break this range to 2 parts, okay? So the part on the top and the part on the bottom. So, and so we will have a hash for the data above this part, okay? So let's say the hash is h1, okay? And for the bottom part data, its hash is h2, okay? Cool. So we have the hash of these 2 segments, okay? And for the above part, we continue to segment its data to half and half, okay? So now let's say after the partition, our data becomes, we have 2 hashes, okay? So still we have hash 1, 1, and hash 1, 2, okay? And similarly for the bottom data, we also break it down, okay, to 2 different data, okay? So let's say we break it down to 2 parts, and now the 2 parts hash are H2, 1. And for this part, it's H2, 2. Okay, so basically you can see it's like a tree, right? So for example, here is a tree, okay? So the root of the tree is the whole data range, right? And the root stores the hash value of the whole data range, okay? So, and then the child, the left tree represents the left child in the tree. It represents the first half of the whole range, and it stores a hash of the first half data, right? And for the right child, it also stores the hash of the other half of the data, right? And then within this child data range, we also break it down to two parts, right? And similarly, we also store the hash for this first part, and also we store the hash for this second part, okay? And it's similar for the right side, right? Mhm. Okay, so basically it's a tree, right? Where the value of each node is a hash of the range of the data that it represents, right? So let's say this is for this machine, right? It has this kind of tree which stores the hashes. So on the other side, this machine also has this tree, right? So in order to see whether there is any data difference, we can just first check the root node to see whether the hash is different or not. If the root nodes hash are the same, it means all the data in the whole data range is the same, right? So then there's no need to sync the data because we know the data are the same, okay? So let's see the hash is different. It means there must be some data which are different in our data range, right? So which part is different? Then we just traverse the tree, right? So first we go to the left side to check whether the left node hash is different or not. Let's say it's the same. Then there's no need to check the left side further because we know the data is the same in this data range, right? So then we goes back to the tree and we continue to check the right side, right? So they will compare the right side node. We found the data is different. Then we continue to go to the left or the right side to see which part is different, right? So with this, we can check, we can go to the leaf node, right? And then we can see which part is different, right? So with this, we can quickly find which data range is different between the two machines, and we only sync that data range data. So this is the Merkle tree, okay? And it's a smart technique to compare the difference between a huge amount of data and quickly detect the difference. Okay, cool. So basically this is the whole content for the DynamoDB, okay? And let's have a retrospect. So in this video, we talked about the APIs for a typical key value store, for example, for DynamoDB, right? We also talked about how to achieve high scalability, which is through the hash rings, right? Or consistent hashing. And also we talked about how to use virtual nodes or virtual machines which uses multiple hash functions to map a single physical machine to multiple virtual machines. So with this, we can achieve evenly distributed traffic, right? So, and we also talk about availability, how to have high availability. It is through the replications, right? And also we talked about how DynamoDB select the replication machines for a data, right? And also we talked about what if some machine dies temporarily? We use the hinted handoff to store the data which should be stored on the dead machine into another machine, right? And when the machine comes back, the other machine, which has a hinted handoff, will give back the data to the dead machine, right? And at last, we talked about the Merkle tree, which is used to sync the data between different machines if there is permanent failures, right? Okay, so that's all about this video. And if you like this video, please give me a like and also subscribe to this channel. Thank you.